Quadratics. Factoring quadratics. A not equal to 1. Remember that the standard form of a quadratic expression is ax squared plus bx plus c, where a does not equal 0. When a is not equal to 1, quadratic expressions are a bit more difficult to factor than when a equals 1, but the process remains the same. Examples 1 and 2. Except when b and c are divisible by a. When that happens, we must first factor a out of each of the terms and then use the box and diamond method on the resulting quadratic inside parentheses. Those will be examples 3 and 4. All right, so let's just start here with example 1. We're going to factor that expression. So notice that the value of a, 6, each of these other two terms are divisible by that value. So we rewrite the original expression with the 6 factored out. So it's going to be 6 times the quantity x squared, because 6x squared divided by the 6 is equal to x squared. And then negative 12x divided by 6 is negative 2x. And negative 18 divided by 6 is negative 3. And so now what we do is we use the box and the diamond method on that right there. So, oops. In the lower left-hand corner, we put the x squared term. In the upper right-hand corner, we put the constant. We take those two, we multiply them, put the result in the top of the diamond. The x term goes into the bottom of the diamond. And now we think, all right, what times what is equal to this? Well, because that is a negative, actually I should say is equal to that. But what I was focusing on was this negative. Since that's a negative, one of these things has to be a positive something x, the other has to be a negative something x. That's the only way we can have a negative when we multiply two things. And we have to multiply and get negative 3x and add and get negative 2x. That's negative 3x squared. Sorry, I'm just tripping over my words today. So it's going to be a negative 3x and a positive 1x. So multiply those together, get negative 3x squared. Add these together, get negative 2x. Bring those two terms over and fill them in either place. Doesn't matter. And now we need to find the height and the width of each of these small parts of the rectangle. So we have x times x is x squared. X times what is 1x? Well, x times 1 is 1x. X times what is negative 3x? Well, x times negative 3 is negative 3x. So now we can rewrite our original expression, but it's important to remember that we factored this 6 out. So when we rewrite it, we need to put that there. And now this is what we're going to rewrite in factored form. And it's going to be the quantity x plus 1 times the quantity x minus 3. And that's example 1. Example 2. Again, we can factor out that 5. So we have 5 times the quantity x squared plus 10x plus, let's see, that's 24. And so now we need to do the box and the diamond on that part right there. So the x squared term, lower left-hand corner, the constant, upper right-hand corner. Multiplying those two together, they go into the top of the diamond. The x term goes into the bottom of the diamond. Because this is positive, this is either both positive or both negative. Since this is also positive, these are both positive. Whoops. They're both positive, and I don't have to write in the positives in there, but I can. And so we need two things that multiply together to give me 24x squared and add together to give me 10x. And it's going to be 4 and 6. And remember, you can write out the list of all those factors to help you determine what it's going to be. Yeah. So bringing those terms over, it's 4x and 6x. So now we need to find the height and the width of the outside of that rectangle. So what times what is x squared? X times x is x squared. X times what is 6x? X times 6 is 6x. X times what is 4x? X times 4 is 4x. And is 6 times 4 24? Yes. Awesome. So again, we need to make sure that we remember that we factored this 5 out. So it's 5 times the quantity, x plus 6. And, we can actually do this one first. X plus 4. It doesn't make any difference because we're multiplying those two quantities. And we can change the order of multiplication, so it doesn't matter which we put first. So we have factored the original expression like that. Example 3. Now here's the situation where A, B, and C, they don't have any common factors, all right? So we just go straight into the box and diamond method. So five x squared goes into the lower left-hand corner. Now that may throw you off that we have a 5x squared there. That's a little different than any we've seen so far. The constant goes into the top right of the diamond. And now we multiply these two together, and 10 times 5 is 50. So I don't really know if I should make it an orange or a green. How about I do this? I'll do 5, so one orange, one green, and 50, and then x squared. Looks a little weird. Maybe I don't think I like that. Let's just do it in orange, 50x squared. But we know we got it from 5x squared times 10x is 50x squared. And now we need to bring the x term and put that in the bottom of the diamond. And this is one of the reasons why these become harder, is because with these bigger numbers, it makes it harder to find the factors. The two numbers here that multiply together to give me 50x squared and add together to give me 27x. Okay, so I know that they have to both be x, and they're both positive because this is positive and this is positive. And 50 and 1 wouldn't work. 25 and 2, that's what works. So 25x and 2x multiply together to give me 50x squared, add together to give me 27x. So now I have 25x and 2x. And now we need to find the outside parts of the box. And what I notice is that in this part right here, these are both divisible by 5. So that means that I'm going to need to put a 5 down here, okay? And 5x. So 5x times what is 5x squared? Well, 5x times x is 5x squared. 5x times what is 25x? Well, 5x times 5 is 25x. And x times what is 2x? X times 2, and we can check. 2 times 5 is 10. Great, that's good news. So we can rewrite the original expression as the quantity, x plus 5, times the quantity, 5x plus 2, and that's good. All right, so we're at a little bit, it's going to take me a little bit longer than I wanted it to on this video, but I hope that it's worth it. So stick with me, folks. Stick with me through this. It's good learning here that you're getting. So this is another situation where these do not have a common divisor, so we can't factor anything out. So we're going to take that 7x squared, go into the lower left-hand corner, take the constant, the 8, and go into the upper right-hand corner. Now we're going to multiply those two together. and we're going to get 56 x squared, because 7 times 8 is 56. And we're going to put that negative 30x into the bottom of the diamond. Whoops, not 330x. Now what I need to notice is that this is positive, which means these can be both positive or both negative. This is positive and this is negative, which means these have to both be negative. Negative something x and negative something x. All right, so 56 and 1, if this were 56 and 1, that wouldn't work for down here. 2 and 28. Oh, yeah, that works. All right, so it's a negative 2x and a negative 28x that I can bring over. And now, this time, I notice that this way, these are both divisible by 7. So I put 7x here, and that makes this an x. 7x times what is negative 28x? 7x times negative 4. X times what is negative 2x? It's negative 2. Negative 2 times negative 4 is 8. So now I can rewrite this, the quantity 7x minus 2 times the quantity x minus 4. And that is factoring quadratics when a does not equal 1.